Chapter 6, clean the air. This is rule number 3, or our third large layer of mitigation for reducing risk of COVID in public spaces like classrooms and offices. To recap, step 1, keep exposed and known sick people at home. Step 2, wear high quality, well-fitting masks to keep the virus out of the air. Step 3 is to clean the air so virus doesn't linger and infect people. First, you want good ventilation. Bring in outdoor air. Open windows and doors. Turn the HVAC from auto to on so it keeps running. While we're thinking about HVAC, you can also add additional filtration to some HVAC systems by using MERV 13 filters to remove the virus. But the basic idea is you want to bring in a lot of outdoor air, and that will reduce COVID risk. CO2 monitors can be used as a proxy for ventilation. If a room has a lot of CO2 in it, it's from people exhaling typically, and there's not a lot of outdoor air coming in. You can Twitter search CO2 monitor or Aranet4, which is a brand of CO2 monitor, ARANET numeral 4, to learn more. I use this to identify places with potentially good or bad ventilation so that I know the risk. Similarly, instead of bringing in outdoor air, you can just filter the air using different types of air cleaners. So I mentioned that in some cases, you can upgrade an HVAC system to filter the air more effectively, but you can also just buy HEPA filters. You can also build do-it-yourself or DIY air cleaners. Often these are called Corsi-Rosenthal boxes, named after 2 engineers who promoted their use from the very start of the pandemic. It just involves taking 1 or more MERV 13 or higher HVAC filters and attaching it to a box fan. The filter isn't quite as strong as HEPA, but the fan is much stronger, so it can clean the air at a faster rate. And often these DIY options cost about 1/8 of a HEPA filter to get the same air cleaning rate. I've built many of these myself with my 5-year-old, with my research lab, and with members of the community. I trust them in my home, in my office. We have a project giving them away to people with cancer to reduce the risk of in-home transmission of COVID, since in-home transmission is so common. They also help with dust, wildfire, and non-COVID airborne illnesses like flu. So they're just a helpful thing to have around with COVID and for other reasons. What's really disturbed me about the pandemic is that we don't often match precautions to the level of risk. If you're in a hospital and somebody was known to have COVID, there would be excellent masking and ventilation. Yet in a K-12 school, there may be 2 to 3 kids with COVID in a classroom right now in many places. No quarantine based on exposures, no testing programs anymore, no isolating based on testing because people aren't doing testing, and often allowing kids in school with mild symptoms, which could be COVID or something else. Very low uptake of vaccines, no masking, horrible air cleaning. Many schools are super spreaders, and we might only have 1 COVID wave per year instead of 2 if it weren't for all of this transmission going on in schools. The failure to match mitigation with risk is completely unnecessary. In the summer of 2023, ASHRAE, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, which is the top organization in the world on indoor air cleaning, made standards for the control of infectious airborne illness. I have a table here for school settings, but in their actual document, they cover bars, restaurants, medical settings, all sorts of different places. There's 2 ways to think about air cleaning. One is to think about how many times you need to clean out the air in a room per hour, called air changes per hour, or ACH for short. If a room has 5 ACH, that means it's cleaning out the air 5 times an hour. The other way is to make it about the number of people rather than the room itself, and have a certain number, a certain air cleaning rate per person. For example, you could clean the air at 50 cubic feet per minute, or CFM, per person. And so if that was your goal, 50 CFM per person, and there were going to be 10 people in the room, you would want 500 CFM or 500 cubic feet per minute total, 50 times the 10 people. The first way was used historically, focusing on air changes per room. The second way is likely better and actually easier to make calculations in terms of like how many HEPA filters or DIY air cleaners do I need for a given space. Some people are coming up with complex formulas that are using both. Anyway, the table just shows the level of air cleaning needed in various school settings. Most of the time, cleaning the air at 40 to 50 cubic feet per minute or CFM per person is sufficient to keep virus from accumulating in the air. The far right column basically just shows that in more densely packed settings where you've got a ton of people, you're going to have greater need for cleaning the air, more cubic feet per minute because there's more people, and that translates into more air changes per hour. So if it's a library where there's not very many people there, you don't need to clean out the air quite as often relative to a giant assembly in a gymnasium where everybody is sitting shoulder to shoulder, 200 people, or a large lecture hall with tons of people, where you're going to need to clean that air at a much higher rate. It really shows the danger of assemblies and large lecture classes. Just about none of these are cleaning the air out of the room 50 times per hour. So they're likely very high transmission events in many cases. My main point is to show you that these standards exist. Most places are not yet following the standards. Many will eventually, and it's a point of advocacy. Many schools, bars, and restaurants are only cleaning the air at 1/6 to 1/30 of what they should be, for example. It's very bizarre that in the most densely packed, inherently high-risk settings, there's often the fewest precautions.